Hello and welcome back to this channel. This is Professor Rajesh Barapate, a book author of 25 plus engineering books. Dear students, today's topic is Norton's Theorem. If you haven't yet watched the earlier videos related to Superposition Theorem and Thevenin's Theorem, I'm advising you to do watch those videos. Presently we are talking about Norton's Theorem. The statement is any linear network containing energy sources. Now, what do you mean by energy sources? Energy sources means it can be either voltage or current source. So, any linear network containing energy sources and resistances can be replaced by constant current source in parallel with single resistance. In simplified language, whatever network you have, it may contain different current sources, different voltage sources and some resistances. Then entire network can be simply represented by a single current source which is constant, not changing with time, and in parallel with the resistance. So basically Norton's theorem, like other theorems like Thevenin's theorem, is used to simplify the network. Now, before solving the numerical, let me tell you what are the steps required for solving the numerical. First step is calculate short circuit current. Second step, calculate equivalent resistance. This is similar to the calculation of equivalent resistance of Thevenin's theorem. I will still explain this part. And last step is draw Norton's equivalent diagram. So to get the things more clear, let us solve few numericals. The problem is find Norton's equivalent network for the given circuit. This is the given circuit. A and B points are already mentioned in the circuit. Now one very important part. Here, nothing is shown between the points A and B. If suppose some resistance would have been shown like this and it is marked as RL, then first step would have been, we would have replaced this resistance and made an open circuit to start with the numerical. Alright, now this is 10 volt voltage source. In earlier videos we already discussed longer terminal indicates positive, shorter terminal indicates negative. These three are three resistances. First step is make a short circuit between points A and B. So I will connect one wire between these 2 points A and B. Whatever current flowing through this wire, short circuit means directly connect one wire between 2 points A and B. Whatever current is flowing through this wire, that is denoted by ISC, short circuit current. Now, by using any technique, I have to calculate this value of ISC. You can use any technique like KVL, KCL and so on. I will be telling you the simplest trick how to calculate the short circuit current ISC. Note that I is current, SC stands for short circuit. Now, instead of applying KVL and KCL, we will be using some different technique. Let us calculate total resistance of this circuit. So, after calculating total resistance, the things will be more clear. Now see, this is a short circuited. These two resistances, 2 ohm and 1 ohm, they are in parallel. A big question arises, how you identified they are in series or parallel. Remember the simplest trick. Whatever resistance you are considering, you are checking it whether they are in series or parallel. If they are in two different wires, this is one wire, this is second wire. If resistances are in different wires, they are in parallel. So this is the short circuit. That means for the simplicity, I can well draw this diagram like this. This 2 ohm I can show over here. This 2 ohm I can shift it over here. Alright. Presently, how to memorize it? Two resistances are in two different wires. So they are in parallel. So I will calculate parallel combination of these two. This is written like this. 2 parallel 1. These two lines indicates parallel combination. How to calculate parallel value? Take the multiplication into numerator, that is 2 into 1 divided by, take the addition, that is 2 plus 1. So this value is 2 by 3. So this value I have calculated. Now next, come back to the voltage source side. What we did, we calculated equivalent value, parallel combination of these two. Next, there is a resistance of 2 ohm. Remember the simple trick. This type of network is called as a ladder network. In almost all cases, just check the first connection. If it is in parallel, second is in series, third is in parallel and so on. So this is in parallel. So next, by default, I will be taking it in series. Therefore, I will write it like this. RT. RT stands for total resistance of the circuit. We have calculated value of parallel combination of these two. Remaining is 2 ohm. So I will write it like this: 2 by 3. What is this 2 by 3? Parallel combination of 2 and 1. And it is in series with 2 ohm. So I will write plus 2 ohm. So if you solve this on the calculator, you will get this answer as 2.67 ohm. This is the value of total resistance. Now, recall the basic Ohm's law. Basic Ohm's law is I is equals to V upon R. In this case, I will say this as total current and resistance as total resistance. So I have denoted it as IT, total current, is equals to V, supply voltage, divided by total resistance. This is the Ohm's law. That's why to calculate total current, I have calculated RT. So in this case, I can write it as 10 upon 2.67. So value of total current will be 3.7453 amperes. Keep in mind, this is the value of total current. What is total current? Total current is the current coming out from the voltage source. So I will mark this total current over here. This is the total current, this current. I will denote it by IT. This is IT. Alright. Now, what is my interest? I have to calculate this current ISC. I have calculated the value of total resistance IT. Same current flows through 2 ohm. This point is called as current division point. How to memorize it? Very simple. Whenever the number of branches gets increased, that means after this point I am getting 2 branches, 2 different branches. So current gets divided it into 2 branches. Up to this point, the current is IT. So after this, there are 2 branches. Through this branch, this IT current is flowing like this. And through this branch, some different current is flowing. I am not interested in this current. What I am interested in? I am interested in calculating ISC. So I will be using current division formula. What is current division formula? One more thing, if you haven't yet watched the video related to basic electronic concepts, do watch it, where I have covered all these basic things. Here we are using current division formula. What I am interested in? I am interested in calculating ISC. What is that formula? ISC is total current. That means in this case I will write IT into, I want to calculate ISC. Formula is ISC is equals to IT. IT is total current into opposite resistance. What is this opposite resistance? See, ISC is passing between A and B. That means it is coming through 2 ohm and then passing through this branch A and B. So I am not considering 2 ohm. What is remaining resistance except 2 ohm? It is 1 ohm, because after this point division start taking place. So I will not be considering this 2 ohm, because always consider the resistance after the point after which the current division starts. This is called as current division point. So formula is total current into remaining resistance or opposite resistance. ISC is passing through 2 ohm. Remaining resistance is 1 divided by addition of resistance. Now common mistakes. Addition of resistance means don't consider this 2 ohm resistance. Addition of resistance means what? Consider the resistance those are present only after current division point. This is the current division point. After this I have 2 resistances, 2 and 1. I won't be considering this 2 ohm resistance, because this 2 ohm resistance is before current division point. So it is 1 plus 2. I haven't considered this 2 ohm for this calculation. So simply if you put the values, so value of IT is 3.7453 into 1 upon 3. So it will give you value of ISC, that is short circuit current, which is 1.2484. This is the first step. What we did, we have calculated the value of short circuit current. Next step is I have to calculate value of equivalent resistance, which is also known as Thevenin's equivalent resistance, denoted by RTH, or it is also denoted by REQ. EQ stands for equivalent resistance. How to do it? This was the previous diagram. Between points A and B, I have marked the current as ISC. First part is remove this branch, remove the short circuited point. Now between A and B, I had marked ISC, I have removed it. Looking from this point towards network, I will repeat, looking from this point towards network. So arrow is like this. We have to calculate value of RTH. There is one more rule you need to remember. After removing short circuit, you have marked RTH just for the starting of calculation of RTH. One more important part is, look at the diagram. If in the diagram remaining sources are voltage sources, short circuit that branch. If there are current sources, open circuit that branch. Only two simple rules you need to follow. So I have marked RTH. Now in the diagram only one voltage source is left. What I said, if it is a voltage source, remove that voltage source and simply join it by a wire which is called as a short circuit. This was the voltage source, so I have short circuited it. Now we have to do the calculation of RTH. One more thing, just for your information. Arrow is like this. It means that we have to start doing the calculation of RTH from the other end. So I have marked RTH at this end between points A and B. Start doing calculations from the other end, that means from this point. Now simple logic. These two are different wires. That means 2 ohm and 1 ohm. They are in parallel. So I will write it like this. 2 parallel 1. How it is calculated? 2 into 1 divided by 2 plus 1, which is 2 by 3.67. Okay. Since this is first combination which was in parallel, next will be in series. So how to do it? So I will directly write RTH is equal to, see, I have calculated parallel combination of 2 and 1, which is 2 by 3. So this 2 by 3, series means plus 2 ohm. Remember this logic. If it is a ladder network, then just identify first combination. If it is in parallel, second is in series. By default, you don't have to do any calculation. So first combination was in parallel, so I took next combination in series. So 2 by 3 plus 2. So this value of RTH will be 2.67 ohm. This was the step 2. We have calculated the value of RTH. Next step is, in the question it is asked to draw Norton's equivalent network. Very simple. This is the third step. How to do it? We have calculated value of ISC. ISC was short circuit current. That value was 1.2484. In parallel with this source, draw value of R equivalent or RTH. So this is RTH, whose value is 2.67 ohm. Then mark these points A and B. This is called as a Norton's equivalent diagram. Now one very important concept. Suppose you want to do the calculation of Thevenin's theorem, and if you don't know the Thevenin's theorem, you know only Norton's theorem, then what to do? This is the last step of Norton's theorem. I want Thevenin's equivalent diagram. Simple trick I will tell you. Consider this value of ISC and RTH. We know the Ohm's law. V is equals to I into R. Just perform multiplication of these two. So it is 1.2484 into 2.67. So this will give me the value of V, rather it is denoted by VTH, which is called as Thevenin's equivalent voltage, which is 3.33 volts. Directly you can draw the Thevenin's equivalent diagram. How to do it? Draw the voltage source of this value. How I got this value? Just by taking multiplication of these two values. So this value is 3.33. This is also denoted by VTH. VTH is Thevenin's equivalent voltage. And in series with this, draw RTH. RTH remains as it is. So in series with this, draw RTH, that is 2.67 ohm. This is called as Thevenin's equivalent diagram. Very simple. In another language, if you know Thevenin's and if you don't know Norton's theorem, then last step of problem will be, you will be getting this diagram after applying Thevenin's. Convert this into this diagram. How to convert it? I have now voltage and resistance. So simply calculate ISC using this formula, VTH upon RTH. You will get value of ISC. This is 1.24. Draw same resistance in parallel. Always and always keep in mind, If you have a current source like this, draw resistance in parallel. If you have a voltage source like in Thevenin's, draw the resistance in series. These are the basic concepts you need to memorize. Now, let us solve some different numerical so that the concepts will be more clear to you. The next problem is using Norton's theorem, calculate current through 5 ohm resistance in the given network. This is the 5 ohm resistance where I have marked points A and B. How to start this numerical? If you straightforward start solving directly by using Norton's theorem, then the calculations will be very lengthy because it contains current source and voltage source. So I will be telling you simplest trick how to remember the things. If there are different sources, like one is current source and another is voltage source, always and always try to convert voltage source in terms of current source, so the calculation will be pretty simple, pretty easy. This is because then there will be only one type of sources. So I will repeat. If there are current source and voltage source, try to convert voltage source in terms of current source just to simplify the calculation. That's it. Now, how to convert it? This is 20 volt voltage source and 2 ohm is in series with voltage source. Very important criteria. While converting voltage source into current source, the resistance must be in series with 20 volt. If it is not, you can't convert it. So, since 20 volt and these 2 ohm are in series, how you came to know that they are in series? Very simple. This is single wire. Just for drawing the diagram, this wire is bent like this. So this is the single wire. That means they are in series. So I will be converting this part into the current source. Now again recall the basic of Ohm's law. We have I is equals to V by R. So if I want to calculate value of current, it becomes 20 upon 2, that is 10 ampere. After doing this calculation, how to draw the resultant diagram? Very simple. What I did, I have converted 20 volt and 2 ohm into current source. So this 2 ohm, remove it, draw it a single wire like this and draw this 2 ohm which was removed in parallel like this. It was in series, it was in horizontal line, draw it in vertical line, that means in parallel, and remove this voltage source by the current source whose value we have already calculated, that is 10 ampere. So remember this simple trick. If there are different types of sources like one voltage source, one current source, try to convert voltage source in terms of current source. After calculating value of current, how to do it? V upon R, it is 10 amperes. Draw that resistance in parallel and replace that voltage source by the current source. Now very much simplified technique is this 2 ohm and 2 ohm, they are in parallel. Very simple because they are in different wires. So I will be doing calculation like this: 2 parallel 2, which is 2 into 2 divided by 2 plus 2, that is equals to 1 ohm. So this parallel combination gives me the value of resistance equals to 1 ohm, and 10 ampere and 2 ampere are also in parallel. How you identified it? See, there is no resistance from this point to this point as well as from between this point to this point. So this is straightway wire and 2 vertical lines are connected. You can well skip this part while thinking of current source. So these 2 are different wires. If suppose there is some resistance, we cannot take these 2 resistance in parallel. Presently it is just joined by 2 simple wire, nothing is there, no element like no resistance is there in between this and this as well as this and this point. So these 2 current sources can be combined into a single source. Very simple. Both the current source are having arrow in upward direction to directly add the values of this current source. So I will be getting value, that is 10 plus 2 is equals to 12 ampere. Now how to draw the resultant diagram? What I did, I have taken parallel combination of these 2 as well as I took these 2 current sources in parallel. So replace one current source and one resistance. So I have removed one current source and one resistance from the diagram, and whatever is remaining, for that draw the calculated values, write the calculated values. So current source now becomes 12 amperes. So I will denote it by 12 amperes. resistance now becomes 1 ohm. This is the simplified diagram which we got just after making few simplification, after using few simplification technique. Now we will start solving the numerical. How to do it? See, this 5 ohm is connected. So what is asked in the question? Using Norton's theorem, calculate current through 5 ohm. So after performing certain simplification, we will be applying normal Norton's theorem steps. How to do it? First step is remove this load, this 5 ohm which is connected between point C and B is called as load resistance, because across this it is asked to calculate the value of current. So remove this load resistance, that is 5 ohm, and simply connect one wire over here. Denote this current as ISC, that is short circuit current. Now my aim is to calculate value of ISC. Look at this diagram. This current is 12 ampere. It is already current, no need to convert it into voltage and all that. It is already the value of current. After this point, up to this point, current is 12 amperes. After this point, some current passes through this branch. Through this branch, same current ISC is passing. So ISC is passing like this. Through the remaining branch, through this 1 ohm, some different current is flowing. What I am interested in? I am interested in calculating value of ISC. Like the previous sum, we will be applying direct current division formula. How to apply it? ISC, I need to calculate this current. What is the formula? Recall the things. It is total current. What is available total current in the circuit? It is 12 amperes into opposite resistance. Except this 2 ohm. Through 2 ohm ISC is flowing. Except this 2 ohm. What is remaining resistance? It is 1 divided by addition of resistance. So addition of these two resistance, that is 2 plus 1. So it is 2 plus 1. So now ISC is 4 ampere. This is the value of short circuit current. Next step, this was the first step what I did. I calculated value of ISC. Second step, I need to calculate RTH or R equivalent, that is the equivalent resistance of the network. How to do this calculation? Simple logic, remove this wire which we have drawn to calculate ISC. From this end, look at the diagram. This resistance is denoted by RTH or R equivalent. Now check the circuit. What is remaining in the circuit? Current source is remaining. I have already told you only two simple rules you need to apply. If remaining source is voltage source, short circuit it. If remaining source is current source, open circuit it. What I did, I marked RTH. Then I am checking what is remaining source. Remaining source is current source. So simply open circuit this. Open circuit means directly remove it. Show it like this. You can well mention this as OC, open circuit. Now, using any technique, I have to calculate RTH. Things are very, very simple now. This 12 ampere is removed, so no current. Now, this is open circuit. That means remaining circuit is like this. For the simplicity, I will draw it like this. This is 1 ohm. Then this is 2 ohm. After this, there is an open circuit. So I haven't drawn any line. And I will mark RTH like this. You might be thinking these are two different wires. No, these are not two different wires. It is a simple single wire. Why? Because this was open circuited. Open circuited means as if wire is removed. Nothing is there after this point. So this is a single wire. So RTH now very simple. RTH is these two are in series because they are in single wire. So RTH is 3 ohm. Now third step. What I need to do in the third step? In the third step, I need to draw the Norton's equivalent diagram. How to draw the Norton's equivalent diagram? Very simple. You need to draw one current source. That is, value of this current source is ISC, which we have already calculated. This value is 4 amperes. And in parallel with this, draw RTH, which we have calculated. So value of RTH is, this is RTH whose value is 3 ohm. These are the points A, B. This is Norton's equivalent diagram like the previous case. But in this numerical, it is asked to calculate current passing through 5 ohm. So after drawing Norton's equivalent diagram, I need to connect the resistance of 5 ohm which I had removed in the first step. through this 5 ohm, whatever current is flowing, that I will be denoting it by IL. IL stands for load current. Now, I need to calculate value of IL. Again, I will apply current division formula. Very simple. This is ISC. Now, consider this as the final circuit. This is ISC. After this point, current gets divided. Some current passes through RTH. Remaining current is IL. I am interested in calculating IL. So recall the formula. IL is equals to total current. Total current in this case is 4 amperes. That is ISC. 4 into opposite resistance. I am interested in calculating IL through 5 ohm. Except 5 ohm. What is remaining resistance? It is 3 ohms. So it is 3 divided by addition of resistance, that is 3 plus 5. So if you do this calculation on the calculator, its value is 1.5 ampere. So this is the final answer. Dear students, I have purposely selected the numericals in such a way that the basic concepts will be more clear to you, so that you can solve any type of numerical as far as Norton's equivalent theorem circuit is considered. And as I mentioned in the earlier problem, you can well convert it into Thevenin's equivalent diagram. So that's it for today's video. Thanks for watching this video. If you like this video, don't forget to smash the like button. Thank you very much.